my hobby now for my last few years is definitively to develop smart batteries. And here, what we are trying to do is try to put kind of, sensing within the battery. And we get like inspiration from the medical field. And if you go to the hospital and you have a surgery, the surgeon is going to put optical fiber into your body in order to know what is going on and can be a good treatment. And now we want to do the same thing. We are putting optical fiber into the batteries in order to determine what will be the lifetime, the state of charge, and so on. Okay, my name is Jean-Marie Tarascon, and I am professor at the Collège de France in Paris. I think, first, I think what I like is to do fundamental research, but useful research. And I think when I entered the field of science, when I started my PhD, it was back to the 1980s, just at the time when we have this kind of oil crisis. And this was really a motivation for me to decide to do research along these kind of topics. And I start my PhD and my postdoc working first on kind of superconducting materials, which are materials that can conduct electricity without Joule effect below kind of temperature, hence saving energy. And turn out that some of these materials are also good for electrodes. And this automatically I kind of shift to the field of batteries and so on. So this is more or less why really I am in this stuff. And I think, why I am passionate. I think because I am very curious and I want to understand how things around me works, and more so, I want to improve them to make them more useful for society. And I think, this is more or less, solving puzzles that I really like it. And the reason why my life is not working is a game. I try to solve puzzles, and here that I develop a passion, I will say. And I think, as a matter of fact, I don't know if you can discover passion, but I think be passionate is certainly the most greatest and most precious gift that I could inherit in life. I think for me is curiosity, conviction, vision, resilience, while keeping open-minded and very attentive, and more so, willing to take risks and think out of the box. So I think if you are different kind of ingredients, I think you will really be very impactful. And I should, even so maybe a lot of people will not share it, I think don't know too much. Because when you know too much, you are not really try to do crazy things. And when you know less, everything for me is wonderful. I am very extremely curious, and sometimes I don't hesitate to challenge tradition. I think in my field is relatively easy, since nowadays, everyone in the world is talking about energy, is talking about batteries, that more or less are the heart of our society and so on. And then I can give this kind of general explanation, and then if I want to go down, I say, I work on kind of materials that can transform a chemical energy to electricity. Well, this is a little complicated, but I do it in order to lower the weight of your portable phone, increase your speaking times, or if you are buying car, to increase the autonomy as well as the charging rate. And I think this really make people understand the type of research that I am doing without going into details of, building structure, putting atoms together and all this kind of stuff and so on, And I think what I have been proud of, I think there are two types. Some, of course, are practical impact, namely the work that I did on the discovery of the plastic bell core technology back to 20 years ago, 30 years ago, and more recently to the sodium-ion technology that we start from the lab and is nowadays into the market. But in my heart, the one that certainly is the most important to me is a fundamental one. Is a fundamental one which goes back to the 2000, where I wrote a paper, a very visionary paper, on other type of reaction mechanism on electron materials that we call anionic redox. And when I published this paper, everyone say, no, this is totally wrong, this is crazy, and so on. And 15 years later, turned out that this crazy idea was right, and nowadays, most of the battery community is working on this type of materials, and this is more or less a drastic transformation, in which, for the last 25 years, people were thinking to use battery or energy by taking advantage of cations, and in this case, we can have both cations and anions that are ideally participating to the total capacity. And this is more or less becoming one of the hottest topics in the battery research nowadays. And here again, that I say sometime in research, you need to be patient, you need to have a resilience and conviction. And now regarding the future, of course, here my hobby now for my last few years is definitively to develop smart batteries. And here, what we are trying to do is try to put kind of, sensing within the battery. And we get like inspiration from the medical field. And if you go to the hospital and you have a surgery, the surgeon is going to put optical fiber into your body in order to know what is going on and can be a good treatment. And now we want to do the same thing. We are putting optical fiber into the batteries in order to determine what will be the lifetime, the state of charge, and so on. So this more or less is a kind of research that I launched about 4 or 5 years ago, and also is a kind of opening a new area where a lot of people now are really moving into it, especially industry, because enable them to have an idea about what's going on into a battery, which once is sealed is really a black box. So this is more or less my last challenge of my life, I think.